Hello. In this class, this is one of the important chapter for 10th class student, that is trigonometry. I already told you there are three parts in trigonometry. The first one is ratios, second one is the complementary, and the third one main important concept, that is trigonometric identities. From this trigonometric identities only, all 10th class students will get a 4 marks question in your annual exam. So in this trigonometric identities, we require to prove something. We will give some to prove. So before proving that, we require to know some trigonometric identities. Then only we can prove the given question properly. The first identity, everybody knows that sin square theta plus cos square theta is equal to 1. The second identity, the basic identity of trigonometry is, I mean, x square theta minus tan square theta is equal to 1. The third identity is cosec square theta minus cot square theta is equal to 1. These three are the basic identities in trigonometry. So we are applying in so many ways. For example, sin square theta plus cos square theta is equal to 1 means from this basic identity, we can write some sub-identities. That is sin square theta is equal to 1 minus cos square theta. In the same way, cosec square theta is equal to 1 plus tan square theta. And cosec square theta, sorry, sec square theta is equal to 1 plus tan square theta. And cosec square theta is equal to 1 plus cot square theta. We can write say, like that some sub-identities. By using these basic identities, we require to know this minimum knowledge about the trigonometric ratios. Tan and cot are the reciprocals. If you multiply tan theta and cot theta, it will be 1. And tan we can write as sin theta by cos theta. Cot also we can write as cos theta by sin theta. And cosec is the reciprocal of sin and sec is the reciprocal of cos. So by using all these trigonometric identities, we require to prove some questions. So how to prove? What are the process? I will tell you by taking some questions. Here my first question is, prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. So here the question is in two parts. This is LHS and this is RHS. If you simplify the LHS, you want to get RHS. Sometimes if you simplify the RHS, you want to get LHS. In some cases, you require to simplify both LHS and RHS, then you will get the same answer. Then we can say that it is true. Hence, it is true. So in my first question, LHS is, in my first question, LHS is, what is LHS? Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. This I want to simplify and I want to get as tan theta. So how it is possible once you check it? So from the numerator, if I make sin theta common, what happened? This will be 1 minus 2 sin square. And in the denominator, if I make cos theta as common, this will be 2 cos square theta minus 1. This is my first step. And here what I am doing, you see, sin theta 1 minus 2 into sin square theta is equal to, I told you from identity 1, sin square theta is equal to 1 minus cos square theta. This is the identity, sub-identity from the basic identities from 1. So sin square theta is equal to 1 minus cos square theta. In place of sin square theta, just I am writing 1 minus cos square theta by, you write the denominator as this cos theta 2 cos square theta minus 1. So what happened, you see, this is sin theta into 1 minus 2 into 1 is 2, minus into minus plus 2 cos square by cos theta into 2 cos square theta minus 1. Here the logic, that is sin theta. First you write 2 cos square theta minus 2 plus 1, it become minus 1 by cos theta into 2 cos square theta minus 1. These two are same. You can cancel. Then this is sin theta by cos theta. So already is there, sin theta by cos theta is equal to tan theta. So this is the RHS. Hence the given question is proved. So here just I used one identity, that is sin square theta is equal to 1 minus cos square theta, while simplifying. At last, what identity I use? Sin theta by cos theta is equal to tan theta. By using these two identities, we proved that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to tan theta. This is one of the important question. And in the first step, just I made sine theta common in the numerator. In the second step, I made cos theta common in the denominator. Then afterwards, this sine square theta just I wrote as a 1 minus cos square theta. Afterwards, if you simplify, these two values will be same. And if you cancel, you will get sine theta by cos theta. That sine theta by cos theta is nothing but the tan theta. So this is the method to solve this question. And in exam, where you are using any identity, you want to mention that identity in the bracket. Due to that identity, you are writing that step. So otherwise, you lost your marks. So every identity you want to mention in the while solving the question. So this is my first question. So second question, we'll take somewhat complicated question in identities only. So here I selected some important questions. And if you solve these questions, by the way, you practice some more questions, it will helpful for your annual exams. And more practice, you will get more perfection. That's all. So my second question is, prove that, prove that tan square theta plus cot square theta plus 2 is equal to sec square theta into cosec square theta. This is a very interesting question. Here, we require to use some knowledge, algebraic knowledge. Here you see my question is tan square theta plus cos square theta, cot square theta plus 2 is equal to, you want to prove the product of sec square theta and cosec square theta. So just simply you write the LHS. What is my LHS? Tan square theta plus cot square theta plus 2. Here in the second step, just I am playing a trick here, that is tan square theta plus cot square theta plus 2 into tan theta into cot theta. Why I wrote tan theta into cot theta? So tan and cot are the reciprocals. If you multiply these two, you will get 1 only, 1 into 2, 2 only. There is no change in the value. But why I wrote here tan theta into cot theta means, if you observe carefully, this is in the form of a square plus b square plus 2ab, that is equal to a plus b whole square. So for that purpose, I wrote 2 as the 2 tan theta into cot theta. Now it will be written as tan theta plus cot theta whole square. That's all. Now afterwards, here what I am applying means tan theta is equal to sin theta by cos theta. So this is sin theta by cos theta plus cot theta is equal to cos theta by sin theta. So whole square. While you are using tan theta is equal to sin theta by cos theta, here cot theta is equal to cos theta by sin theta, you want to mention in the bracket what identities you use here while solving this question in the examination. Otherwise, you lost your marks. Then the next step is, what is the LCM? Cos theta sin theta by crossing sin square theta plus cos square theta whole square. In the next step, you know that sin square theta plus cos square theta is equal to 1. This is 1 by cos theta into sin theta whole square. Now, distribute the denominators. I write like this, cos theta whole square into 1 by sin theta whole square. This become 1 by cos square theta and this become 1 by sin square theta. 1 by cos, you know that 1 by cos is the sec square theta it becomes, and this is becomes cosec square theta. So this is my RHS. So while solving this question, here 2, 3 identities we used. Those identities we require to put in your answer. In the first case, just I wrote 2 as the 2 into tan theta into cot theta, because tan and cot are the reciprocals. There is no change in the value. Why I wrote like this means I want to convert the LHS in the form of a plus b whole square. So this becomes tan theta plus cot theta whole square. Here, first identity, in place of tan, I wrote sin theta by cos theta, and cot theta is equal to cos theta by sin theta. Afterwards, if we go for the LCM, this becomes sin square theta plus cos square theta by cos theta into sin theta. Again, I used one identity, that is sin square theta plus cos square theta is 1. and cos theta into sin theta. Just I distributed the square for both 1 by cos whole square and 1 by sin whole square. 1 by cos again here, and I used 1 by cos is sec and 1 by sin is cosec. So it becomes sec square theta into cosec square theta. The RHS also sec square theta into cosec square theta. Therefore, LHS is equals to RHS. Hence, the given question is proved. So while solving these type of questions, you have some caliber on identities. Should have some experience how to use these identities according to the given question. Then only it is easy to solve. So more practice. You practice more on these questions, you will get some experience. Afterwards, you feel very easy to solve these type of questions. So this is also very important question. So many times it was asked in your exam. Okay, I will go for the third question. This third question also very interesting. So my third question is, prove that cosec theta minus cot theta. This is somewhat easy. Cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So this is one of the interesting question. Cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So if you see LHS is cosec theta minus cot theta. This is whole square. Next, first identity what I am using here, cosec theta is equal to 1 by sin theta. So this is 1 by sin theta minus cot theta is equal to cos theta by sin theta. This is whole square. Here, if I go for the LCM, sin theta, this is sin theta, it is nothing but 1 minus cos theta whole square. If you write the square for the numerator and denominator, it becomes 1 minus cos theta whole square by sin square theta. Up to here, I think there is no doubt. But here, what I am doing, here just in first step, I applied cosec is 1 by sin and cot is cos by sin. You want to mention why 1 by sin, because cosec is 1 by sin, cot is cos by sin. You want to mention in your answer. So here what I am doing, we see 1 minus cos theta whole square, I can write 1 minus cos theta into 1 minus cos theta. A plus b whole square is equal to a plus b into a plus b. So here sin square theta is equal, if you see the first identity, sin square theta is equal to, I already told you, if I send cos square theta to that side, 1 minus cos square theta. So here in place of sin square theta, I can write 1 minus cos square theta. So next step, this is very important step, 1 minus cos theta and 1 minus cos theta. If you see the denominator, this is in the form of a square minus b square. One I can write 1 square minus cos square theta. This is in the form of a square minus b square. A square minus b square is equal to a plus b into a minus b. A square minus b square is equal to a plus b into a minus b. If you write in that form, this is 1 minus cos theta into 1 plus cos theta. That's all. So this two will be cancelled. Then 1 minus cos theta by 1 plus cos theta. So this is the RHS and LHS is equals to RHS. Hence the given question is proved. So just if you observe the LHS, cosecant cot is there. Just that cosecant cot I converted into sin and cos terms due to cosec is 1 by sine and sine and cot is cos by sine. After taking the LCM, just here apply it is sin square theta is 1 minus cos square theta. You need to concentrate on this. 1 minus cos square theta is in the form of a square minus b square. Just as expand it a plus b into a minus b. That is 1 minus cos theta into 1 plus cos theta. This 1 minus cos theta, 1 minus get cancelled. Then your answer is 1 minus cos theta by 1 plus cos theta. That is our RHS. So this is also very interesting question and you can solve it easily. We'll go for the next question. This next question also very interesting. I selected some important questions. Here, the fourth question, under root of prove that under root of 1 minus sine theta by 1 plus sine theta is equal to sec theta minus tan theta. LHS is in sine terms and RHS is in sec and tan terms. Here I require to prove this one is equal to this one. So question is prove that 1 minus sine theta by 1 plus sine theta, the root is equal to sec theta minus tan theta. So here just I want to go for the LHS. LHS is under root of 1 minus sine theta by 1 plus sine theta. If question is under root, in any question, if the question is under root, you go for the rationalization, you get 1 plus sine theta is there, you multiply 1 minus sine theta by 1 minus sine theta. I mean, the both numerator and denominator, just I multiply with 1 minus sine theta. What happened, you see? So this is under root of 1 minus sine theta whole square. And this is a plus b into a minus b. That is nothing but a square minus b square. This become 1 minus sine square theta. So this is under root of 1 minus sine theta whole square by, here I am applying one rule, that is 1 minus sine square theta is equal to cos square theta. So this is under root of 1 minus sine theta by cos theta. A square by b square, I can write a by b whole square. This square and this will be cancelled. My LHS value, I got 1 minus sine theta by cos theta. But RHS is not like that. RHS is sec theta minus tan theta, but I got LHS value is 1 minus sine theta by cos theta. I told you in before, while I am starting the class, sometimes you're required to simplify the RHS also, then only you will get the answer. For that purpose, I selected this question. You see, RHS is sec theta minus tan theta. Sec theta I can write 1 by cos theta minus sine tan theta I can write it as sine theta by cos theta. You mentioned that rules in beside that question. So LCM is cos theta. So this is 1 minus sine theta. Now you see RHS value is 1 minus sine theta by cos theta and LHS value also 1 minus sine theta by cos theta. Therefore, LHS is equals to RHS. Both are equal. Hence, my question is proved. So sometimes without RHS also you can simplify, but it is somewhat complicated. But simplest way is in this type of questions, you do the simplification of LHS and afterwards you simplify the RHS, then you will get the same answer. See here 1 minus sine theta by cos theta, here also 1 minus sine theta by cos theta. Then easily you can say that LHS is equals to RHS. This is also one pattern question. If the question is like this, you go for the rationalization. I mean, you multiply the numerator and denominator 1 minus sine theta by cos theta. So it is easy to solve this type of question. Thank you. And we will go for the next pattern question. This is also very interesting. If anybody is having doubts, you can put those questions in my channel and I will explain those questions through that channel only. In your NCRT, there are so many questions, but I selected some important questions here. So the fifth question, it is very complicated and very interesting. That is cosec theta by cosec theta minus 1 plus cosec theta by cosec theta plus 1 is equal to 2 sec theta. 2 sec square theta, I'm sorry. So this is the question. Cosec theta by cosec theta minus 1 plus cosec theta by cosec theta plus 1 is equal to 2 sec square theta. If you see this question, it is very, by looking, it is very complicated, but it is very, very easy. So just you take the LHS. LHS is cosec theta by cosec theta minus 1 plus cosec theta by cosec theta plus 1. Just you go for the LCM. This is a minus b into a plus b. This is nothing but cosec square theta minus 1. Direct step I wrote. Next, this one into this one, cosec theta into cosec theta, this is cosec square theta, plus this into this cosec theta, plus cosec theta into cosec theta, cosec square theta, this is minus cosec theta. Plus cosec theta minus cosec theta get cancelled. Cosec square theta plus cosec square theta, 2 cosec square theta by cosec square theta minus 1. So now we require to use an identity that is cosec square theta minus 1. You see, cosec square theta minus 1 is equal to cot square theta. If you send take 1 to this side and send cot square theta to that side, then you will get that cosec square theta minus 1 is equal to cot square theta. This rule, this identity I'm using here. In place of cosec square theta minus 1, I will write as cot square theta. Then the next step is to cosec square theta by cot square theta, because cosec square theta minus 1 is equal to cot square theta. Now what I am doing, 2 into cosec is 1 by sin square theta, cot is cos square theta by sin square theta. Then the step is 1 by sin square theta into, will become the reciprocal. This is sin square theta by cos square theta. Sin square theta, sin square theta. 2 into 1 by cos square theta. This become 2 sec square theta. So here, once again, I will explain. There are two, three identities I used here. The first identity is a minus b into a plus b. In the case of LCM here, I wrote a square minus b square. That is cosec square theta minus 1. After writing this, here cosec square theta minus 1, I wrote here cot square theta. And afterwards, here this step is very, very important. Cosec square theta is equal to 1 by sin square theta, I wrote. And cot square theta is equal to cos square theta by sin square theta. And if you simplify it, it will become 2 into 1 by sin square theta into the denominator become reciprocal while multiplying. So this is sin square theta by cos square theta, sin square theta cancel. This become 2 into 1 by cos square theta. Again 1 by cos square theta is the sec square theta. So this simplification of my LHS becomes 2 sec square theta, that is RHS. That is RHS. Therefore, LHS is equal to RHS. In this all question, just I used this type of identities and I simplified every question. I got LHS is equals to RHS. So there are so many different types of questions in your NCERT textbook or state syllabus book. You practice those questions by using these trigonometric identities. When you practice more, then only you will get some experience. Then only it is easy to solve these type of questions. If you have any doubts in your NCERT textbook or your state's textbook, you put those doubts in my channel and I will explain those questions in easy way and practice more, get perfection and get good marks. Thank you.